So welcome everybody. Thank you for joining us. We had a really interesting talk about transformers just now. And so now we're going to have another really interesting talk about simplifying MLOps stack. So Andrey is the creator of dstack. He's passionate about open source and developer tools for AI. He used to work at JetBrains with the PyCharm team. And yes, we're really happy to welcome him. Thank you for his time. And yes, thank you for coming.
Thank you, Martin and Muhtasham for having me. Excited to talk about MLOps and dstack today. So yeah, looking forward to it. Then let me share the screen and I shall begin. Right, just confirm that you can see the screen.
Yeah, it works. Thank you.
All right, so yeah, so in this talk we're gonna talk about MLOps and MLOps stack. And when we say stack, we typically mean developer tools and technologies used to work with MLOps. And the essential topic of that talk, let's say, is going to be around how to simplify the stack, right? And we'll start with the intro, and in particular, what MLOps is. So yeah, as if you follow the topic, you might see that it's been talked a lot here and there. And it's kind of trendy to talk about MLOps, and sometimes there's a lot of confusion about what MLOps is, what it is not, and how to have it. I'm in this topic for quite some time already, and to be honest, myself, I still sometimes get confused, and there are many aspects about MLOps which beg for clarification at all. And if you, for example, go to Wikipedia and try to see what MLOps is, typically MLOps is described as a set of practices to help folks and teams deploy machine learning more efficiently to production. And what is the source of the confusion is often which exactly practices are we talking about? And if you even try to Google, okay, so what are the best practices? Then there'll be different opinions about that. And instead, you'll hear a lot of people talking about tools rather than practices. And I think it is more important to talk not just about tools, but about these very specific practices and principles behind MLOps. And it's also interesting to think of DevOps as analogy to MLOps. So, well, these two terms are a bit similar, and you might notice that. So, for example, DevOps was coined much longer time ago, and MLOps is a relatively new thing. And yeah, these terms have some similarity in terms of they kind of combine two things together. For example, DevOps combines devs and operations, and DevOps stands for combining developer practices and operational practices, basically bridging these practices together and letting developers be involved in operations rather than having two different silos. So so you can imagine that the MLOps has some similarity with DevOps, and it combines two camps. One is ML, which sometimes is also called data science or AI, and the other one is ops. So, and we can think in different way about MLOps. So in this particular slide, I suggest that we look at the fundamental tasks that we deal with when we talk about MLOps. And just like I said, there are two different camps. One is machine learning, which is all about experimentation. And sorry, the other one is about operations, which is a lot about versioning and automation. So when we talk about experimentation and machine learning, we typically mean all these things which you do when you want to experiment. So you start with looking into the data, you explore it, you do exploratory data analysis. Then you may prototype a model. Basically, when we say prototype in a model, we mean training a model. But that training is meant to be in this interactive form, where we at the same time train a model and explore things and play with the model. And finally, of course, when you prototype something, it is always important to collaborate with other folks. That's why it is important to share models and code. And this is something that sometimes people might disagree with. And maybe just to mention as a disclaimer here, this talk is my personal subjective view into the topic, and it is totally fine if, well, there are different points of view, and if you find that you disagree with some points, that's totally fine. We can take it to the Q&A session, and I'll be very happy to discuss this. But having said that, sometimes I see confusion, and sometimes people say, okay, so experimentation has nothing to do with MLOps, because MLOps is all about operations, about deployment of the model and all. And this is something that I find personally hard to agree with, because again, if we think of the MLOps as of bridging two different camps, it means that we bridge the camp of experimentation with the camp of deployment. So which means that experimentation is in fact a part of the MLOps story. And finally, when we look at the operational side, and what fundamental tasks are there? Like number one is processing data. So if with the experimentation stage, we just explore data, play with it a bit, try to process it interactively. When it comes to operations and automation, we have to set up a pipeline that processes data and prepares it. And then, of course, retraining of the models. And what we mean by that is that at the experimentation stage, you might train a model. But what is important is when you start shipping the model into production, it's not just a model which you've trained at the experimentation stage, but it's a reproducible model, which means that you know exactly how to reproduce that, and you basically retrain that using the fresh data and try to improve it. So basically, we are in this iterative, incremental improvement loop. And of course, deployment of the model is a part of these operations. And you may wonder, okay, so why these two camps are different camps? Why do they exist? And it's quite useful to look at this from the perspective of roles, basically, like what kind of mindsets of people that are involved in this. And if we do that, we'll clearly see that these mindsets are different for the experimentation and for the automation. And well, there are many different terms how to call these roles. In this particular presentation, I call this role that is involved with in experimentation AI researcher. We can also use the words terms data scientist, and some others. But if we talk about machine learning, the modern machine learning, well, it's quite common that this role is called AI researcher. And on the operational side of things, we typically distinguish two roles. Data engineer, this is someone who is automating the processing of the data that is used in training of the models, and of course the software engineer. And here it's quite wide term, which means many different things. So, for example, when we talk about deployment is done by dev teams. It's just that these folks leverage the practices of the DevOps, and they are involved in deployment of the models, right? And it's also interesting to look at not just roles and tasks, but also tools which these folks use. And when you've been registering for the talk, you might see in this picture with lots of different logos of different tools, basically like hundreds of different tools. So the idea was for this picture was to show, okay, so there are so many different tools and how to stay sane. Well, there are so many tools, how to navigate yourself over this tool. So basically, what we know about tools, that there are plenty. There is so many different tools. But in this particular slide, let's say, I'd like to highlight not some tools, but rather fundamental tools, some very essential tools that are used in most of the cases, and for some important reasons. So, for example, when we talk about the experimentation, of course, experimentation is hard to imagine without notebooks. And there's a lot of different talks about, okay, so notebooks are great, notebooks are not great, you should use them, you should not use them. But what is certain is that notebooks is a great way to experiment and to interactively explore data and have very short feedback loop, which is super important. And that's one fundamental tool. And the other fundamental tool is experiment trackers. So today it's really hard to imagine that you might train a model without using experiment trackers. So that's what it makes fundamental. I mean, and if you train a model, you probably know that. In fact, there are so many different kinds of experiment trackers, but the essential idea is that when you train a model, you store metrics. And then you can compare these metrics to understand, okay, so which experiment is better, which experiment would be taken into the deployment or to the production. And now, speaking about operations, I put into this list the following tools, like the IDE. When it comes to automation, we typically don't use notebooks. We typically use scripts. And to be able to work with the scripts most like efficiently, we typically use IDEs. We also can call them code editors. For example, there are different kind of IDE/code editors. There's PyCharm, there's VS Code, there's Vim, and others. And the other fundamental tool is, of course, Git. Git is as a fundamental tool to version code, which is essential for operations, and also CI/CD, which helps us automate the pipeline. When there's a new version of code, we can run certain tasks, be it running tests or deploying something. And two others are, well, three others are Docker. Docker is the standard de facto for packaging things for deployment. So today, Docker is probably the main standard. If you want to ship something, if you want to deploy something, the easiest way to do that is through Docker. And finally, in order to deploy something or to automate something, we need infrastructure. And in order to manage that infrastructure, the easiest way to do that is typically infrastructure as code toolkits such as Terraform, Kubernetes, and some others. Right. Yep. Are there any questions related to that slide, or no? We can continue that. Yeah. So so now that we went through 3 different perspectives of what MLOps is, like tasks, roles, and tools, there is an important question. Okay, so how do we drive MLOps practices? What should we do in order to have people leverage these practices, to embrace them? And there is no, let's say, one answer which everyone in the community agree with. So there are different opinions. Some people talk about tools, some people talk about the culture, some people talk, for example, that it is not possible to merge data science and software development. Data scientists are fundamentally different from developers, and it's not possible to teach developers data science, just like it's not possible to teach data scientists development. And in this particular talk, I personally like to suggest my personal thinking about that. So one way to think of MLOps is draw this parallel line with DevOps. So DevOps has changed the industry significantly by helping developers make it easier to deploy software. And basically, the idea for DevOps is okay. So yes, there are 2 silos, developers and ops people, and there is a lot of friction between them. So what we should do is to empower developer people to do ops without actually ops people being involved. So basically, DevOps means teaching every developer to be involved in operations. And if we make that analogy, then in MLOps, that would mean that we should empower every AI researcher to be involved in operations. And what that means is I've made a list of some principles. Okay, so just theoretically speaking, if we agree to do that, if we agree to empower AI researchers to be involved in operations, what are these principles which we should focus on for AI researchers? And so because we're talking about the automation and the ease of automation, by today, there's the main way to automate certain things is to codify them in code, and providing tools that allow to run this codified thing. So, for example, when we talk about DevOps, it's how do we provision infrastructure? We codify infrastructure with code and then provision that infrastructure through tools like Docker and Terraform. So it boils down to versioning code, which is important. So you cannot deploy models which are not versioned. You have to know which models you've deployed and how you can reproduce that model. Of course, you have to version dependencies, because if you want to provision something, you really know how to install that and how to deploy that. you have to version dependencies. Because you deploy models into infrastructure, you need to version that infrastructure as well. So you have to basically have it in code. And finally, of course, when we use data, we need to version that data too. So that would be my personal list of things that are important if we want to empower AI researchers to be involved in operations. And so this slide is in my view is quite interesting, as it talks about the complexity. So when we talk about the MLOps stack, we typically means different kind of tools. So it means that every AI researcher or every team with folks of different roles, they might have different tools. And the question is, if we want to simplify the MLOps stack, if we want to increase the productivity, if we want to find a way of not wasting time on what doesn't matter, so we need to answer the fundamental question: how do we choose tools which we work with? And there is a ton of different aspects how to do that. And in this particular slide, I'd like to present you one very simple framework, how I personally think of tools applied to MLOps. So here you see the chart where there are different tools, and you can see that complexity grows. So on the left, the complexity is very small, and on the right, the complexity is very high. So in the left side, we see libraries. Libraries is the easiest, they have lowest complexity, which means that they are most simple to use. So why is that, and what do we mean by that? So for example, when you train models, you might use different kind of Python packages which you reference from your Python code. So these things are called libraries, sometimes also frameworks, but the more common word here would be library. You import that library from your Python code and you reference that, and that's very easy to do. It doesn't create additional complexity because your program is running the pretty much same way, and it doesn't matter what library you use. The way you need to run your program or deploy your program doesn't change. So when you add additional libraries, you don't increase your complexity of your stack, which is why libraries are the most popular way of doing something. So for example, there is a library for processing data, there is a library for training models, there are libraries that help you also manage dependencies and environment. And for example, there is PyTorch Lightning library, which also help you leverage multi-GPU training just from your Python code. For example, if you compare with PyTorch, if you compare PyTorch and PyTorch Lightning, with PyTorch, you need to do some additional things, complex things, in order to train your model on multiple GPUs. You have to spawn multiple processes. You need to take care about the communication between them. And for example, compared to PyTorch Lightning is just one Python library call, and it's taken care automatically. So that makes libraries the easiest way to do something. And the next one is CLI. So why are we talking about, what is the CLI and why we're talking about CLIs? CLI is a command line interface, or we can also call them command line utilities. These are things which you can call from the terminal. And again, why they have low complexity, why they are so simple. It's because you can run them pretty much same way as basically any CLI can be run pretty much same way from your terminal. For example, if you're working with an IDE or with the terminal, you don't need to install anything or configure anything or write additional code. The library is installed pretty much simple way, and you can call it. So an example is Docker, an example is Git, an example is Python itself is a CLI library. You install it once, and then you can use it as you want. So this makes CLIs very powerful and simple tool. Then we might have API. So what is the API? Basically, it's typically the most typical form of an API is an HTTP endpoint provided by some service. For example, here we mean managed service, a service managed by someone else. So we don't have to manage that service. All we need to do is to consume that API through certain interface, and there can be many different interfaces to consume an APIs. For example, when you work with weight and biases as an experiment tracker, as a managed experiment tracker, you might use the Python library for that. But this Python library inside, it's actually is using HTTP endpoints from weight and biases managed service. So how APIs are simple, and at the same time they are more complex than libraries and CLI. So they are simple because the service itself managed by someone else, and you don't have to manage that complexity. So weight and biases manage that all for you. It provides its interface for you. You don't need to worry how it works, who has to deploy it, who has to install it, who has to update it. All you need to do is to use a Python library in your code, which talks to that endpoint. But then you can ask, okay, so yeah, they are simple tools, but why they are more complex than libraries or CLI? And well, that's obvious, because those services are not owned by you. You depend on some third party to provide that service. For example, you cannot influence what features are provided by that service, or when certain bugs are fixed. So you don't own it fully. It's owned by someone else, and it might stop working as you expect it to work at any point of time. Might be not likely, but still there is a possibility of that. And for example, if you use a library or a CLI, you don't need to be afraid of that. But that's the case for the API. Still, it makes the APIs a very simple tools, and that's why, for example, if you compare weight and biases with some other, let's say, tools. For example, there is TensorBoard library, which allows you to set up this dashboard, let's say, with your metrics. It's not that easy to understand which way is easier. So there are different factors. For example, with weight and biases, or Comet, for example, for that matter, it's easy in a sense that you don't need to install that server, that dashboard. You don't need to manage that. All you need to use the API. But for example, if you're using TensorBoard library or MLflow library, or let's say application rather, then you have to manage them yourself, and that creates additional complexity, giving you additional flexibility. So that being said, the next one is applications, and maybe here it's worth to tell that this is quite relative. It's quite relative when we talk about the complexity of different tools, and it's really difficult to categorize one tool into one category. For example, when we talk about MLflow, on one hand, it is a library. On the other hand, it's a CLI which runs the application. And it's not just CLI, it's application that you need to run. And sometimes you can run it locally. Sometimes you need, when you, for example, want to collaborate with someone, you need to install that web application within your network and configure it so other people can access it, which makes it quite complex journey. And you have to bear in mind how much complexity you want to take within your stack. Finally, the ultimate complexity is provided by platforms, so-called platforms. So what is a platform? A platform is typically a large set of different tools combined together. For example, Kubeflow or SageMaker or Vertex AI or some other tools that basically come in a combination of different tools. So it may consist of a number of libraries, a number of APIs. It might come with different applications inside. Then if these all things integrated together and they kind of designed to work together, then this thing is typically called the platform. Sometimes, for example, when we talk about MLOps platforms, we also call them end-to-end platform, meaning that this platform provides all of the tools for every stage of their journey. For example, it might provide own experiment tracker, it might provide own library for training, it might provide own dashboard, up to even own ID. So, and that's the worst part of it, that it's not just a lot of tools that have to work together and you have to basically follow the way they are designed. It's also that you cannot really use some other tools. Sometimes you can, but it's difficult to use some other tools. For example, if you are using some MLOps platform, for you it's really hard to use, for example, some service from other vendor. Basically, you typically pushed into using all the services from one vendor, from the vendor of the platform. And that's what creates this complexity, because typically these MLOps platforms are very complex. They cover everything. They provide a lot of tools. They update these tools. The vendor updates these tools, and that serves as a source of the complexity and also the inflexibility. So up to, like I said, when you work with MLOps platforms, you even need to work with an ID provided by that vendor. For example, if you're using SageMaker, you have to use, well, not have, but you kind of pushed into using the SageMaker Studio, which is an ID which integrates all of the tools together. Compared, for example, if your stack would consist of libraries, CLIs, or APIs, and you would be able to work with an ID, like, for example, PyCharm or VS Code. Right. Yeah. So basically, that's all about the MLOps. I wonder if we have questions, Martin, about that first part.
Yeah. So you show the fundamental task for MLOps on your first slide, which also shows the basic MLOps process. At which step do you see the most problems when working with larger companies? Is it the deployment and retraining process, or is it already in an earlier step?
Right. So basically, the question is, what are the most challenging parts, right? What are the most challenging tasks, right? Yes. So that's a good question. And I believe that, like you said, most of the challenges are related to the operational side of things. So until today, there have been a lot of different ways of exploring data, prototyping models. So that's what basically makes data science, right? About it's all about exploring data, prototyping models, and then sharing models. And there's been tremendous progress recently. For example, there is Streamlit as a way to share applications. There's Gradio, there is Hugging Face as a way to share models and then consume models from your environment. There's of course all these libraries and visualization libraries that help you explore data. And now people start, of course, to wonder how can they deploy that. And if you go to different communities and you hear what people talk about, you'll see that data scientists coming from the data science mindset, they experience tremendous challenge of applying that engineering practices, which have to do with versioning the environment, managing dependencies, and packaging and deployment of the model. So basically, like a typical question is, okay, I have a model, what format do I convert it to? How do I package it into Docker? Should I use Flask, or should I use, I don't know, some kind of a platform? Should I use a managed service, or should I do it myself? So basically, there is no standard for that today. There is standards for exploring data. There's many standards for prototyping models. There is standards now for sharing models, but there is a lack of standards when it comes to packaging models. And then speaking about retraining, there are some approaches. Basically, there are many ways to organize your pipeline. So, for example, you can use CI/CD to run your pipeline. You can also use different cloud, let's say, platform kind of features. For example, Azure, AWS, GCP, they provide these platforms. But the problem is the complexity, like I said. So, for example, there's not, some people use these platforms, and of course they not always happy about that because there is a lot of complexity. For example, if you go to some end-to-end MLOps platform, you quickly realize that you have to click a lot in the interface. So instead of working with your favorite IDE and writing code, you find yourself basically like this click style development, which doesn't actually always bring to the right result, expected result. Yeah. Sorry for long answer. Hope it answers the question.
Thank you for a long answer. So do you have more of your presentation, or can I do a little bit more questions?
We can do questions. So it seems that I've already spent more time than I planned, and I don't really want to, to show the rest very quickly. So maybe it makes sense to go through the questions and then finish that topic. And well, if we don't have more time this time, then fine. We can, for example, I don't know, take dstack as to some other episode, let's say.
Okay. So I have a few more. I have a few dstack questions, but I'm first going to round it up like this part with another question that's not related to dstack. So are there some risk or semi-related? Are there some risk or disadvantages we're going the open source route, or do the open source contributions completely outweigh the risks?
Right. So the question is, as far as I get it, is about risks of using open source versus not open source, right?
Mm-hmm. Or yeah. Yes, or publishing something that is open source. Yeah.
Means risk in publishing something as open source.
Yes.
Yeah. So it's kind of, again, if I got it right, it seems like it's several questions mixed into one, and probably I'll start with the second one, like of risks publishing something open source. Again, this is a subjective thing, and people can disagree about that and have personal opinions about that. So I personally think that that's the most reliable way of doing something if you can afford it, to make it open source. Why? because by making it open source, you make it transparent. And by making it transparent, you protect yourself from certain things that could be hidden or unnoticed. But then, of course, there are questions about security. So, for example, if what you do is super sensitive, and it highly depends on something being hidden, that's something to worry about and to think twice, because on one hand, of course, you want to protect yourself. On the other hand, you may think whether just by making it not open source, whether it's a really reliable protection. So it easily can be that it's not a reliable protection at all. So maybe it would make sense to think of some other protection, and rather than hoping that just making something not open source will protect you from that risk. And
thank you.
Yeah.
So I have a general question, which is very encompassing, but maybe if you have just like general advices for any, of course, in the context of what we're talking about, like general advices for junior developers or even students, because I think a lot of our listeners are also students, a lot of them from LMU and TUM.
Right. Yeah, it's on one hand it's easy to give advices, on the other hand also hard. Well, to be honest, I envy a lot these folks, young folks that joined this industry today. For example, when I started, I was also very much curious about machine learning, and I remember that first course published by Stanford with Andrey about machine learning, and back then it sounded like really intriguing. But at the same time, if you, for example, compare what is possible today with what was possible back then, it's just incredible what possibilities actually lie here today within this industry. And what makes it even better is that it's not just that some opportunities that you really need to do something really hard or make a lot of efforts into making it, into grasping that opportunities are within your reach today. So look at these transformers, at their diffusion model. So my advice would be to just if you like that topic, just go and try build something that you might have fun with. So that, I think, would be the best way. So even rather than, for example, there's a lot of people that go and take classes. Well, if you can, try to avoid these classes and just try to go and build something, follow someone else's work, take someone else model or take someone else script to train that model, and just try to basically replicate that result and then have some fun with it. So that would be my advice. What would I do if I had more time to do.
If you had it as easy as we have it right now, to put it simply, fine. Yeah, so it's super democratized. Not only knowledge, but also tools. Like everything is basically there, and it's
absolutely
either free or it's super cheap, and you can just imagine telling somebody 10 years ago that you're gonna train neural networks on a MacBook Air. I mean, this would be an insane idea back then. So yeah.
Absolutely. Yeah, there are different free GPU programs. There are credits for startups. There are different grants and programs by by ML companies like Hugging Face, for example, now also offer some grants for cool projects. So if you have a cool project, you'll find a lot of different ways to train it and to deploy it.
Some of the questions are about dstack. So if you have anything prepared about it, I would like to first let you talk about it, and then we can have some questions.
Right. Yeah. And I apologize again for spending more time for the first part. So
nothing to apologize. It's great so far. So thank you.
Cool. Yeah. Hope folks are not sleeping already. Right. So dstack is an open source tool which we which kind of was in a kind of semi-stealth mode, and we just announced in public a week ago. So dstack is a command line utility like Git or like Docker. It's a small command line command which you can run from a terminal. And what that command does is it helps you provision infrastructure to run ML workflows. When we talk about ML workflows, we mean anything you want to do, like to train a model. It could be preparing data, running a script that prepares data, or running a script that trains model, or even runs a script that host an application or some kind of dashboard for ML. And typically when you want to process data or train model, your local machine is not enough. And because maybe you don't have memory or GPU, and you often think, okay, so I would run it, but I need some GPU or memory. So how do I do that? So sometimes you can use, for example, remote machine, or like Google Colab, or some MLOps platform. And what we do at dstack, so instead of using some Jupyter notebooks or some services by MLOps platforms, we offer a very lightweight, developer-friendly command line utility, so you can run any script from your IDE, from the terminal. So let me show you how it works very briefly. I hope you can see my screen. So here's the website. Here's the Git repository on GitHub, and if you go there, you'll find that basically the README file consists of several short sections: how it works, installation, and usage example. So let me briefly walk you through how it works. Let me switch to our IDE. So this is the IDE I use every day. What we have here is a project files. It's under Git. I also have terminal here, and I actually feel really productive using this IDE because it has Git integration, because it has rich code editor, it has terminal. So basically it has everything that I need to be productive running any Python ML workflow. So here I have a download script, which will download some already prepared data. I have a train script. This is a very simple project, of course. This is a project that trains a NIST model, but it can be pretty much anything. For example, when you want to run your script, you typically write something like that. For example, NIST download.py or train.py, and then it runs locally. And what dstack makes it possible to do pretty much same, but when you run that command, it will basically provision in a cloud which you configured the infrastructure to run your workflow. So let me show an example. So how it works. First of all, you have to install dstack pip package, then you need to make this short configuration where you typically choose which S3 bucket you want to store the metadata and the artifacts, and then which regions you want to use to provision your infrastructure. Then, of course, you, for example, have this file with AWS credentials configured locally, and that's pretty much everything you need in order to use dstack. So you need an AWS account. So right now dstack supports only AWS, but other cloud providers already in our roadmap. You need only to have AWS credentials and then basically install that CLI. And then what you do, you create that workflows.yaml file where you define all your workflows you want to run with dstack. So for example, in this particular example, we have two workflows. One is download data, and here we tell how to run it. So basically, here's the requirements.txt, dependencies it needs, here's the file which we need to run. And then it produces the output folder data, and we mark it as an output artifact. So that is it. So now we can run this workflow using this command. I'm sorry, it's just the ID. And what it will do is within a minute, it will create a cloud instance according to their description of that workflow. And then here, for example, we may tell which exactly resources we need. For example, if we need GPU, we can write, we need 1 GPU, or we need 4 GPU, or we need, for example, a GPU of very specific kind. And then when we run that workflow, dstack will provision an instance that matches that requirements, and it will install the dependencies, it will run the script, and then it will save the output as an artifact. For example, if you open another terminal, and then you can run, for example, dstack ps. This is the command. Yeah, we basically run it twice. So let me maybe stop the first one. And keep only the second. So basically this dstack ps command, it shows the running processes or recently finished processes. And using these two commands, we basically can do pretty much everything we want. We can run any workflow, or we can monitor that. And once it's finished, for example, we can also use this command, for example, artifacts, and then we can tell, okay, show me the artifacts of that particular run. Also, you can assign tags. For example, if this workflow will finish, you can assign a tag to it. And then you can use that tag to use that artifact from other workflows. So for example, here's the workflow train that uses the data with the tag Munich data. So basically how it worked, we run the download workflow once we've added a tag Munich data there. So now we reference that artifact of the first workflow through this tag. So when we run the train workflow, it will download and reuse that data. And this way, you can actually you don't have to use this feature if you don't need it, but if you want, you can use it to manage your data. So basically, to version the outputs. And here is how tags work. There's a command tags, which showed you your tags. So for example, here we see that we've created earlier, before that presentation, I ran it once, we've created NIST data tag. And we can also, for example, look what is inside this tag using this command, and then it will show what files are there. So basically, that is mostly it. This is a little utility, and what it helps you with is with this tool, you don't need an MLOps platform. you can provision infrastructure to run your ML workflows while you staying within your ID where you feel productive. That's a very short presentation of dstack, and would be happy to answer questions if there are any.
Thanks for the demo. If anyone has any more questions, feel free to post them in the chat. If not, either I'm going to ask another question or we can go on.
Yeah, go ahead.
So, okay. So I see no questions right now, no fresh questions in the chat. So yeah.
Yeah, I would just add that it was a very short one. So if you are intrigued, just go to their GitHub repo, and there's also a link to their documentation where you find a lot of different examples, the source code for the tutorial, and you can basically play with that. And yeah, if there are any questions, there's also the Slack channel where you can ask any question and I'll answer. Yeah, meanwhile we can proceed.
So it's also kind of a general question, but the question is basically, why did you decide to build this as an open source platform? And maybe as a co-founder, what motivated you generally, and maybe even specifically if you had something more specific in mind that motivated you.
Right. So first of all, why I built dstack? So like I said, I do care a lot about the developer productivity, and it's really painful to see, for example, how sometimes people have to use this end-to-end MLOps platforms where they, instead of using their favorite ID and writing modular code or version it through Git and sorry, use basically this developer tools which help you later productize your model. So you have to use this end-to-end MLOps platforms and use Jupyter notebooks instead of IDs. And I decided, yeah, so people do that simply because there is no way to run ML workflows productively and conveniently from the IDE. So I thought we just need a tool that would be an extension of an IDE to provision infrastructure to run ML workflows, because infrastructure, well, plays a big role in running an ML workflow. It's just typically not possible to run your ML workflow without having this infrastructure. And I thought, okay, so we need a way to make it really simple to provision infrastructure.
Thank you. I think Muhtasham would like to ask a question.
Yeah, first of all, thank you very much, Andrey. A really great talk. Also, your presentation was really good. I think maybe you can also write it as a white paper and also publish it, because I think it will maybe help standardize somehow. I mean, I was wondering, is there an MLOps kind of foundation, just like in Cloud Foundation, they had a lot of lack of standardization as far as I know. And then this Cloud Native Foundation somehow popped up, and then especially with Docker and stuff, they started standardizing some processes, and maybe it.
Yeah. Well, to be honest, I don't know any let's say there are many different communities that do care about MLOps and tools, but I would agree that there is no one, like, for example, in development, there was an agile movement, right? So with the agile movement, it was basically a movement. There was manifesto, and there was very clear ideas how to move forward. So I wish there was such a thing for MLOps. And for example, when somebody asked me, okay, so if I would write this manifesto, what would I talk? I typically say that I would talk about the GitOps. So and most of the time I don't really use the word MLOps. I rather use the word GitOps, meaning that we should use we should integrate Git, and we should version the code which we use to train models or deploy models.
Yeah, thank you very much for your answer. And one more follow-up question. I see after the announcement of dstack, many people in the Twitter and in the comments were kind of resistant to using new tool and stuff. So maybe I think you can create a meme about it, that why dstack is better than kind of somehow those tools, and maybe it will help the adoption of dstack faster, because there seems to be a kind of resistance, I think, to the new tools from the community of developers. So I think this may help you. And yeah,
absolutely, yeah, I do agree. And yeah, so if you want to help, like totally appreciate it.
Yeah, sure.
And I think it takes time, and like you said, people sometimes resist new things, and it takes a lot of efforts to do that. So we plan to do that, and we highly appreciate any help. And finally, you mentioned that maybe we should write a paper on that. So this is also something that I could use help. So if someone would like to write a paper on that, I would be happy to assist. And that would be really great to do.
So for the community, do check out the blog posts of dstack. Andrey writes very good blog posts. I've been reading for over past year. I totally recommend. Go give some love, start the repository, and wish you all the best in this journey of yours. Yeah, thank you very much again. Thank you everyone for joining. And yeah, if Andrey has some closing remarks.
Thanks for having me. Yeah, so happy to meet you guys here. It's basically was my first one joining this community, and looking forward to others. And a message to everyone: yeah, please check out the dstack Git repo, give us a star, and also join the Slack, and I'll be happy to talk about MLOps or dstack or anything else related to machine learning. Otherwise, yeah, wish you a great evening. So at least on my end, it's evening. And yeah,
thank you. This was very interesting.